Okay, here we are going to be looking at static equilibrium in a ladder leaning against a smooth wall resting on a rough ground. It's leaning on a smooth wall resting on a rough ground. So that is what we have. That is the diagram here. Now, but I want you to notice that the ladder leaning on a smooth wall and on a rough ground has four forces acting on it. Four different forces. Number one is W, which is the weight of the ladder. Of course, always don't forget that the weight is acting downwards, and also the weight is acting at the center of gravity. So in this case here, we are assuming that the weight of the ladder is a uniform ladder. To be uniform means that the weight is evenly distributed. So the weight W acts at the center, which is what we have here. And N1 is the second force, which is the normal reaction on the wall. Remember that normal reaction is always perpendicular to the surface. Okay, so we have your N1 here, which is the normal reaction to the wall. And there is no friction on the wall. So, but N2 is the normal reaction on the ground. Of course, whenever an object stays on the ground, there is a normal, reaction. Okay, there is a normal reaction. Then we have, finally, we have F, which is a frictional force. Remember that this wall, this ladder, has a frictional force, which is F, like we see in the diagram here. The normal reaction and the frictional force. Remember, friction always moves to oppose motion. So that is exactly what we have. So let's see if we can answer questions here. Now, if we take moment, okay, before we answer question, if we take moment about x here, about the x, you can take moment about y, you can take moment about x. Now, you can see that your n1 h, n1, let's direct it towards s. N1 should move this way, okay. This one, there is no moment since the both of them are exactly on x. So the weight here, W towards x, should move this way. Okay. So your N1 times H, the moment of N1 is N1H, because H is the perpendicular distance of N1. And H is the height of the ladder above the ground. Okay. Then for W, it will be W times A over 2 cos theta. That's because the perpendicular distance, remember, moment is force times perpendicular distance. The perpendicular distance is A over 2. Now, I want to show you something quickly here. If this is the weight and this is theta, the angle, now the perpendicular distance this is A over 2. Perpendicular distance should be somewhere here. That means the distance that is perpendicular to the weight. And this is theta also because of alternate angle. So you can see that if here is A over 2, this distance is A over 2, it means that the perpendicular distance will be A over 2 cos theta. Okay, according to resolution of force. So that means the moment now will be weight times A over 2 then cos theta. So that is how it works. Okay, so that leads us to a question. Here it says a uniform ladder of weight 50 newtons leans on a smooth vertical wall at a height of 4 meters above the ground. So the height of the ladder above the ground is 4 meters. The base of the ladder on the rough floor is 3 meters from the wall. Okay. If a man of 20 newtons is at a position of 1/4 up the ladder, calculate I, the normal reaction on the wall and on the floor. Okay. Then I is, we're asked to find the frictional force on the ground. First of all, we have to draw the diagram. Now look at this. That is a diagram. But before then, let's try this together. So we have, this is the wall, this is the ground, okay, and a ladder 50 newtons. So this is the ladder here. The weight here is 50 newtons. Remember, weight always acts at the center, so we have 50 newtons. 50 newtons leans on a vertical wall at the height 4 meters above the ground. So the height of the ladder above the ground is 4 meters. The base of the ladder on the floor is 3 meters from the wall. This is the base. The base means under the ladder. It is 3 meters from the wall, so we have here to be 3 meters. If a man of weight 20 newtons is at a position 1/4 the ladder, they didn't give us anything about the length of the ladder, but we can find the length actually, because if here is 4 meters and here is 3 meters, the length shouldn't be a problem. We can use Pythagoras theorem to find the length. That means the length will now be equal to square root of 4 squared plus 3 squared. Okay, that will give me 5, so 5 meters. So meaning that the weight of this ladder is at a point 2.5. Okay, 2.5 here. Then the one that says the weight of 20 newtons, 3 meters, 1/4 up the ladder, 20 newtons, 1/4. 1/4 of 5 newtons is 1.25. It's somewhere here. It's somewhere here. Okay, so this is where the 20 newtons is. And 1/4, that means 1.25. Okay, so the normal reaction on the wall and the floor is with this. Now we can now make our calculations. Okay, so let's see the diagram that I have here quickly. So you see that's exactly what we have. I've shown you why it is 2.5 and 1.25 because of Pythagoras theorem. Now if you notice, theta is the problem. So let's go. This is it here. Okay, so the length of the ladder can be obtained using Pythagoras theorem, which is square root of 4 squared plus 3 squared, which is 5 meters. Hence, the weight is concentrated at a point 5/2, that's at the midpoint, that's 2.5 meters. And the man is at a position 1/4 times 1/5, which is, that's 1/4 times 5, which is 1.25 meters on the ladder. I've shown you that. Now, taking moment about x, okay, we are going to have that n1 times 4. N1, 4 is the perpendicular distance of M1, equal to 50 times 2.5, actually should be 2.5 cos theta, plus 20 times 1.25 cos theta, but cos theta is common, that's why we factorize cos theta here. Cos theta is common, that is why cos theta is factorized here. Okay, so that is very, very important. So we have n1 times 4 equal to 125 plus 25 times 3/5. Cos theta is 3/5. Because cos theta is meant to be adjacent over cos theta is meant to be adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. Okay, from the diagram. Remember, adjacent is the other angle. This is opposite facing the angle. The longest side is the hypotenuse, then while the other side is the adjacent here. Okay, so n1 times 4 is equal to 150 times 3/5, because 125 plus 25 is 150. n1 times 4 equal to 90, so n1 is equal to 22.5. So that is how we get our n1 is 22.5. Now we can go ahead to find n2 and n3. There, let's see, the next question we are asked to find is to find the frictional force. Now, I want you to notice something here. Remember that another condition for equilibrium is that the sum of upward forces must be equal to the sum of downward forces. Okay, so you can see that both N1 and F are moving in opposite direction. The 50 newtons force and the 20 newtons force, if we direct them to the horizontal, they are going to look like this. This is the horizontal. Okay, they are all on the vertical. Okay, so they don't have any moment on the horizontal. So we can simply say here that the frictional force and N1, both of them are moving in opposite direction. So we have F is equal to N1. Since they are in equilibrium, those are the only forces acting on the what is it called now, horizontal. But to find N2, we can say that N2 is equal to N2 now is equal to 50 plus 20, and that will give us 70 newtons. That shouldn't be a problem because they are moving in opposite directions. Okay. Now